where modeling goes one step towards physical modeling. And one of these nodes is here in Vienna, and this is one of a group of, let's say, industrial innovation corners, because the other OMiLAB nodes are at universities and have more the research in focus, and we as an industrial OMiLAB provider have more the industrial and commercial aspects in mind. And this goes right to the topic, which is here the digital transformation. And therefore we said industrial digital environments in action, because what do you see actually as digital transformation? And in my presentation, I would a little bit present some slides to get, let's say, set up the scenes. But more, I would like to show you the actual tools and also the links where you can download more or less everything I'm showing, because most of our software is open use and open source. And invite you, whenever you think there is an aspect you are interested in, download and make your initiatives on those topics. So this is somehow the scene of the presentation, some of the slides to get the scenes, showing the tools. Please note that these are prototypes in these European projects and this cooperation with universities and research centers. Our company develops prototypes. And when they have a certain level of technical readiness, then we are moving this to our commercial software development department, and that's a totally different stream. So whatever I show now, you feel free to download, use, and explore. And if you have questions, either contact audixx.org or, of course, me personally. I'm very happy for all the questions. And therefore, we initially set up what is digital transformation, and why we think that the OMiLAB Innovation Corner as, let's say, a modeling environment can help in these aspects. And then we identify 3 layers. We identify the business layer, and the business layer we would like to address with the result of an EU project called Change to Twin, where we support with this OMiLAB Innovation Corner the modeling of business models. The second layer is what we call the organizational layer, organizational models. And here we would like to present the results of the EU project BIMA, where we provide with the OMiLAB Innovation Corner organizational models like digital twinning of business processes. And then the third level, and this is maybe the most interesting and new aspect in this modeling, is coming down to a physical environment, in our case, the robots. So the question is, how can this OMiLAB Innovation Corner support the modeling of robot interaction? And here I would like to present you the results of an Austrian-funded project, Comply, where we model the robot interaction. So this is what I want to present in the next couple of minutes, so I have to hurry up and go right into the topic of what is digital transformation. There is a study of the World Economic Forum that estimates, together with Arthur de Little, saying that there is $100 trillion in the next 10 years as a market, and essential, sorry. Yeah. And now the question is not if it's 100 trillion, if it's more or less, but for us as an industry, this is an interesting market and this is a need, and our customers will come us, or actually are coming to us, asking exactly this question: what is digital transformation? How can we apply? And we as a modeling company need to have modeling approaches to support this digital transformation. Now, what is digital transformation? I would like to show you two, let's say, samples. This is a YouTube video from LEGO. Now, so we have here on YouTube, I can play a little bit. So, and as you can see, this is a LEGO film. What has this to do with digital transformation? Now, what you see is actually a film. If you search a little bit around, there are cinema films, there are series, there are advertising. So making films with LEGO stones is one aspect and has also some sort of business. The original idea from LEGO was more or less that they have a design environment, a 3D design environment, and which is a software tool, and they give this 3D design environment for free, actually with the intention that people are building their own Lego boxes. So you can design your own Lego box, maybe a company who would like to have a special edition, and then these Lego stones were produced. And this visualization was actually only used to design the Lego stones. This was, the attention had been drawn to Warner Bros., a film industry, and said, that's a good device to actually design this type of environment, because those stones you see here in the scene, they are actually never produced, but they are only designed in this design environment. Now, what has this to do with digital transformation? Lego said, I give a software tool, in that case, a 3D design environment for Lego stones. So I provide a software tool for free in the open market. And then there was a totally new business model, because making films was never the intention of Lego. So there were play stones. So what we are saying is that there is a new business model with new partners, with the film industry, that totally using an existing software tool in a totally different environment and aspects. So this is what we see as digital transformation. The concept behind is the open ecosystem. So you provide something openly in an ecosystem and develop a digital ecosystem. So you make new business, and the principle behind is the open ecosystem. Another sample is what we have is not digital transformation, but more digital optimization. So this is often confused because digital optimization means that you're performing the same business model, but with a digital technology. So digital transformation, in our view, is that you're doing a new business model which was not available before, like Playstone, Lego, and now environment in the film industry. A new business model. Digital optimization is where you use digital technology to improve what you actually did before. And here we have a sample of the roller coaster of Mack Industry, which is a German well-known roller coaster producer and also provider in the Rust. So it's a park where they actually provide also roller coaster. And they have the challenge that because people can download their virtual reality classes and can play roller coasters actually in their living room, so they don't need to go to Rust, which is beside Stuttgart, but quite far away. So you really have to travel to this park, what you see here. Actually, if you're in the home office at home, you can, with your virtual reality glasses, have a similar experience. So they fear, because of this digital technology, a loss of market and a loss of customers. Now, what they did was that they combined and they produced the first worldwide virtual roller coaster, which is a hybrid roller coaster. What does it mean? It means that everybody who goes there and sits on the actual roller coaster, you see here, gets a virtual reality class. And by moving around the roller coaster, he gets the perfect image. This is what you see here. So they are really physically sitting in a roller coaster. They get the VR glasses, and they really have the exact movements in the virtual reality according the movements of the vehicle. Now, what is the challenge? I'm trying to get, this is very good. Here I can show this. Let me get this thing away here. Thank you. Because what is the challenge now? I think it's obvious that this is what we call, the principle is called super user experience. So improving the user experience in using the product. In that case, the product is a roller coaster, and the improvement, the user experience is that they don't have the typical roller coaster, but virtual reality glasses attached. Now, what is the challenge? The challenge is the synchronization of each individual glasses to the movements of the car, otherwise people get sick. So if you see some different movement than the body feels, then this is not a good experience. So the key knowledge is high performance supercomputing, real-time image processing. So a company that was a specialist in building roller coasters, metals, are now supercomputer image recognition and real-time rendering. And this is a total new competence. So in that case, you can say this is a digital transformation still, because it's the same business what we are providing. We stick to the term digital optimization. In that case, it was super user experience. Now, having this introduction that there is a huge market out there, and on the other side, we have different concepts, and this is also very risky. Because investing a lot of money, the estimation of what the business innovation should look like and what are the risks, this is an ideal application field for model-based approaches, because people would like to test this in a secure sandbox environment. They can play around with some simulations of different business models, and then step by step go into more detail. And this is what we support actually with our OMiLAB. It's an open model initiative laboratory, and there is this full innovation corner. What does it include? Here you can see a picture. This is actually here in Vienna, and you can access this virtually. So here you see a couple of tables. On the floor you see physical devices like drones, IoT sensors, robot arms, etc., etc. So here you can test and elaborate how to model a physical interaction, the interaction with sensors, the interaction with drones, the interaction with robot arms, etc. So really the physical devices, which is new in this, let's say, model environment, in this organizational modeling. On the middle layer, so here you see some plexiglass tables. Here we have what we call conceptual modeling layer. So here we model what we typically know with the business processes and organizational diagrams and flowcharts. So this is our environment where we provide our modeling approaches. And then you see some tables on top, which we call business layer, which gives this digital transformation and innovation characteristics to the floor. And now I would like to explain you all three layers. How do we deal with the business modeling? How do we deal with the organizational modeling? And how do we deal with the physical modeling? Now let's start with the top layer. The top layer is the business modeling, and everybody of you, of course, knows the several methods of business modeling. So we do not want to prefer one or the other. If you like business model canvas, E3 modeling, thread modeling, or scene modeling, or whatever you prefer. What we are saying is we would like to have a haptic interaction to include also non-modeling expert in this business innovation process, because in that stage you are having people like managing directors, innovation engineers, maybe maintenance people, so really technicians, so really people who do not have modeling as their daily business. So the modeling needs to be a bit differently presented. And therefore, we applied what we're calling scene to model in this Change to Twin project. Change to Twin project is a Horizon 2020 project. It started in June. These are the 18 companies. It's a digital innovation hub network, and everybody can join because we have open calls next year and the year after if you would like to participate with a digital twin in the manufacturing area. So the idea is that digital innovation hubs, which are research centers, universities, help SMEs in providing digital twin technology, digital twin technologies. So we have a marketplace, and the idea is a digital innovation hub, like a research center university, comes together with an SME in the manufacturing industry, for example, a painting producing SME, and then they come to the laboratory and then say, okay, how can you digitize your business process, your production process? And then also estimate, do you would like to have an optimization strategy, which is in most cases the case, that you simply introduce technology with the same business model, or do you also elaborate a little bit on new business models? I provide the slides in the back because they are then published you can have a look. Just to say that our principle is a methodological principle to identify so-called innovation items, and those innovation items are then pushed to a certain level of technical readiness, and then they are handed over to the customer or to the production department. Now here we have a couple of so-called innovation shops. I'm opening one that you get an idea of what the innovation shop is. An innovation shop for us is a presentation of items. Now, so our projects always result with a stable presentation of items. There are some from BOC, but also some from the other partners. For example, if you would like to see here SAS camera support, this is an innovation items, a short introduction, and then information and even the source code or the demo code. So whenever you are interested in one of these innovation items, you can connect, and there are 3 different ways you can deploy them. So this is something which is automatically used. You simply get a contact to somebody, or it's a multi-tenant SaaS provision. So this really depends of the owner of this innovation item. So first, we identify that each research center, each partner, each industry provides an item which can actually be used. And then is the question, how can these items be used in a setup, what we say a scene to model? Now, scene to model is, for example, here you see some paper figures, and we have several installations, local installations and on-site installations, where you can cut your figures, and you have here the QR code. A camera is reading the QR code, and it is automatically transforming this into a model. So this is scene to model. This has been already published by OMiLAB. If you are interested, you can download the local package, as well as we are hosting the figures here virtually. So this, I think, is a way of modeling where you can put physically the paper snippets, and then you generate a concept model. So this you can download and see. On the other side, we have innovation shop with items, and we are modeling this item again in a modeling environment. And now we would like to match and say for which idea we can provide which items. And then there we have an ontology that makes a matching and proposes a result to the consultant. This is what I would like to show. First of all, here we have our scenes. For time reasons, I'm showing already the imported models. So this, for example, is a scene where there is an assembly. So these are objects which have been recognized with the QR codes. And here we have what we're calling a group element, which is here, the group element. This is something which we additionally provide because here we would like to have the reference to what we are calling a transit model type. So a transit model type is between our modeling environment and external systems. So not to let's say, interfere the modeling environment which is inside the modeling tool, we have an additional transit model layer, and this interacts with the third-party tool. In our case, our third-party tool is an ontology. So we have here the different ontology terms. We can start now a web service which accesses the TLL file, reads the TLL file, and provides you with a simple list of the concepts. Now you select the concept, and the selected concept is then stored in the model. So you have a third-party ontology, you select the concept, and then you can edit. Of course, how complex this ontology is depends on the TLL file and the model of this ontology. So this is what we're saying, semantic enrichment of the original model. This model is now semantically enriched. In the same way, we use this cloud socket. So these are exactly the same items what you saw before. So here is the item, the PaaS SaaS support on the camera. And again, you have this transit reference here. So grouping these elements, and grouping these elements again goes to the description, the requirements description. So here in the requirement description, again, you have the access to the semantic modeling. So again, now the web service is started, and here you have the concepts. Now, now we played around with the concepts. You would like to export them now. Let's make an XML export. I take all of them. I get rid of those, including so now we have here, let's say 2020 1127 poem. I'm exporting. Okay. So now I exported, and now I'm opening the matcher. I'm now opening the file in the matcher which we just created. Let me quickly have a look. I think it was on change to twin. It was here, the models. Yes, and this is the file which we just created, which is a normal AutoXX XML export. So everybody who knows AutoXX, you can download it for free and generate this XML export. Now this matcher gets both the scenes as well as the ontologies. So we have the shop order assembly, and now you see the matching which of the marketplaces actually provide objects that fulfill the needs of those requirements. Now, this is the current result. We are still improving, because the challenge which we are currently working with the Digital Innovation Hub from Norway, TNO, is what is the appropriate ontology that can semantically lift business models to apply the correct technology. I give one sample in the production area. If you have a color producer who wants to model, digitize the production process, and who wants to model how the raw material goes from the warehouse inbound to the production line, you need to have a digitization concept. This can be a RFID, this can be a QR, this can be weights, this can be a camera, this can be many technologies. And to select the appropriate one, we would like to approach this one, that you can pick from different technologies and then make suggestions. Now, if you would like to play around with the full setting, meaning how to get the paper figures, how to get with the camera the scenes, how to add the semantic enrichment to those type of models, here is the link. So this is changed to twin downloads, and here you have the downloads. I'm showing you this also here in a nice on the web page. So in the web page of AutoXX Export, you go to the development community, development spaces, and here you will see the project change to twin. And if you would like to download the package, here you will see it's very, let's say, in the startup phase. But these are the last packages. If you download them, you simply unzip it, and then you start in a sequence the different programs. Now, this was the first approach, how we actually access the business models. Now I need to hurry up, so I'm closing down all of this, because now we would like to have a look on our organizational modeling. So I think that's it. The organizational modeling here, like in BIMR. BIMR is again a European Horizon 2020 project, which is on the renovation of construction sites, energy efficiency, and one type of tool are the process management tools. So this is where we are located, and the question is, you have a building and you would like to renovate the facade, and the whole process of renovating the facade should be, let's say, supported. And one way of support is to estimate the quality and the time and the costs, but also not backward looking, which is a typical monitoring with key performance indicators, but also forward looking, which means you want to simulate the business process, but not only simulating with past data, but simulating it with aspect assessment, how the future will be. So that's the core. We would like to have a forward looking process simulation based on experts. Here, there are some details. I don't want to go into too much detail because of the time, but basically where this process simulation is located is in the continuous weekly monitoring of the construction site. So there are different templates. A high-level templates need to be instantiated to a concrete site. So here you see from a high-level business process template to an instance to a concrete workflow. So you see how the complexity expands. And now we would like to show you how this forward-looking simulation and backward-looking monitoring is actually performed. There are some slides in more detail. Of course, they are available, and you can also download then the package. So if you download the package and unzip the package, you see something like this. And then you start by double-clicking on the BAT file with 1. You double-click the BAT file 2. Here, of course, if you would like to change the models, then of course you need also to generate an RxX. In that case, we are using a traditional BPMN. So this is just to show you that there are BPMN processes underneath. So here we start the wiki page, and we also open the local running Beamer dashboard. So here you see a dashboard which actually consists of a KPI dashboard, and this is a dashboard which we provide for free. You can place the different images, you can locate the different KPIs, and you can also see the development of the KPIs here on the right. Actually, this is only a different view of the model. What is behind is actually a business process, and you allocate different KPIs to certain activities in the business process. In that particular sample, it is a scaffold. So if you make a facade on the house, you need a scaffold, and you have to pay each day for the rent of this scaffold. So you have an estimation of how long a facade renovation for example, 1,000 square meters facade lasts. And this is the is value of the scaffold. And then you would like to have different scenarios, optimistic, moderate, or pessimistic scenarios, to see in the future if the cost of the scaffold will actually be always the same, because if there is a storm or heavy weather and you have to stop the construction site, you still have to pay the scaffold. So the team can go to another construction site, but the scaffold is something which you have to pay all the time. And therefore you would like to have an estimation regarding the weather, regarding how trustful the subcontractors are, regarding how trustful the client is. And these are all influence factors that make either the scaffold let the costs explode or be within the estimated bandwidth. In more detail, you have KPI models, and you can download all the KPI modeling environment, which in that case actually also have a trustworthiness indicator. So what you can see here is that this indicator is actually red. The trust level is 60% because it has been calculated, and you do not know how this calculation is correct or not. For example, here you have an expert who's estimated it simply, so there is no algorithm. So what we added is not only the key performance indicator, accessing the data and merging it with the semantic of the KPI, but also introducing a trustworthiness indicator. Now let's have a look how you can actually simulate this. Now I prepared a small simulation Excel sheet. And then just to start at the beginning, of course, you all know the normal distribution. And basically, in the normal distribution, you have this A value, and the A value says how thick or how thin this normal deviation is. So we are using the typical standard 2. And what we also want to do is that it's not only one aspect which we would like to run or look at, but we would like to have several aspects. So for example, the time calculation here, Yes, here is the time calculation. So what we see is that, for example, the expert says, I'm now playing around, now this says between 20 and 14 minutes, and I would like to weight the level of the expert with 50%. And here we have our normal distribution with a mean of 20 days, and of course a deviation of 3, which has then this deviation. But this deviation again is with only 50%. So the weighted summary is 50% of the 17 and 50% of the 20, and these together is these 18.55 minutes. And this is then translated to milliseconds, because this is what we need for the simulation. So what we can show here is that there is a time dependent, because each run you can estimate the time. So for example, you can vary the time, and you can identify different input factors, and these different input factors are then weighted. And this again with a simulation. So for example, you can say Monday morning you have a different probability than in the afternoon, or in summer you have a different probability than in winter. So this difference you can have here in different inputs of these files. And now I'm showing you one sample. Where are we now? Here. Yes, here. So this is what we call the knowledge-based simulation. We prepared a couple of files. For example, here the test file. And now I have also to choose the test Excel. And now we are running a PetriNet-based simulation. And of course, you can open the results. So what you see here, when it opens, yes, I would like to convert, it's a CSV file. What you can see here is actually the result, how often the gateways used path A and path B, because if you look now in the Excel sheet, you will see that I massively pushed path A because of the expert estimations, and I rated it very higher. And if you can play around with the likelihood, you will see the different distributions. Based on the different paths, you also see the different times. And at the very beginning, this is a very simple one, because we all start at the same time, but you can introduce a time-dependent path analysis. So if you're interested to use time-dependent path analysis with introducing several factors, then this is what we provide. To get a bit more, let's say, a challenging scenario, if you unzip here under model simulations, there are different optimistic, pessimistic Excel sheets. And here you have for example, installation of safety manner, building the scaffold. You see how in the different run there are different input factors, and how you actually can simulate the future, the estimated future behavior. Now, this is something what we provided as backward-looking KPIs, including the semantic description of data and showing them according to the model, and forward-looking simulation, where we then assess how we expect the future. If you want to know if the forward-looking future was correct or not, or if you would like to learn, of course, there is a combination with XWiki. So we can share this experience, and with collaboration of everybody, we can export the model in Wiki and import the comments again to the model to have let's say a manual or human-driven reflection. And of course, there is an interface with process mining also to Celonis, that you can have it also a feedback on a more, let's say, a calculation-based approach. Now, this is what I prepared for the second part. The second part, as mentioned, is the organizational modeling. So in the slides, what I showed you now very quickly is explained a bit in more detail. In that particular case, the estimated time is estimation, it's a knowledge. You have a weather forecast, the customer payment problem. If the customer does not pay, you have to stop the site. The subcontractor failure, so if some subcontractor fails, you have to stop the site. Unknown issues, and also expert assessment, let's say this feeling. And you have different weighted summaries, and this goes to the simple process which I just showed you. So here are the results, some interaction. And if you would like to download whatever I showed you, this is the link. The slides are here, but I also show you, of course, in AutoXX. So if you go in AutoXX, again, the developer community, development spaces, and that was the BIMA project. Where is the BIMA project? Here is the BIMA project. And if you want to download whatever I showed you, here you have the full package. So this is all the components. And then for each individual component, you have explanatory videos, slides. So you can have a look on the design, on the KPIs, on the process mining, on the model wiki, so on the simulation. So for each of the services, you have separated videos, download packages to test, or the full package, which is here. So this is how we are using this OMiLAB Innovation Corner for the organizational part. And some of you may notice that, well, till now, we only were talking about models, okay, with the physical devices at the beginning, but in the middle layer, this is what we all know. But where is now the jump to this digitizing, to the digital transformation, where we need digital technology? And this is done in the last, let's say, sequence of my talk, which is an Austrian-funded project, which is complied to ensure that a robot behaves according certified models. So you model a business process, you certify the business process, and then you send this business process to the robot, and the robot is only allowed to perform certified business processes. So this is a study. More to come, because it's the first, let's say, field study. And how do we certify? We certify it according security and safety criteria. We certify according legal criteria, and we certify according ethical criteria. So there are questionnaires and there are situations that a business process has to be safe, secure, ethical, compliable, and legally okay. And this is performed in the modeling system. And when the business process had this certification, then this is sent to a robot environment, and the industrial robot behaves according this business process. Now, as an application field, we have the supermarket. Currently, we do not have a concrete application fields. We have some in mind, but as an innovation playground, we are using the digital supermarket with self-driving shopping carts, with no cash supermarket where people can go in and out and pay with RFID. There's traffic control, etc., etc. So what we would like to focus in our sample is, for example, an assembly robot, because an assembly robot, the so-called pick and place, is very well known also in the industrial area. Now, on the right side, you have an industrial robot, which is on the Austrian Research Laboratory of Uranium Research in Klagenfurt. So they have an industrial robot in their robotic laboratory, and there is a workflow engine, and this workflow engine interprets a business process called with a BPMN format in order to steer the movements of this industrial robot. Now, this industrial robot is very expensive, it's very secure and safe, and therefore we are not allowed to access this robot, and for sure not for experimentation. So what we did was a proxy environment, which is called simulation with software in the loop, not hardware in the loop, but software in the loop. So a digital twin, which goes till the software, not to the hardware. And then we are using the same workflow engine. We are using the same APIs from the industrial robot, but only they are logging and not actually performing the movements. And we are using the same BPMN here. No? So this is the proxy setup. In order to now design this BPMN, we are using our OMiLAB Innovation Corner with a demonstration robot environment. In our case, it's a Dobot Magician, which is a small industrial robot, but actually for demo purposes, test purposes built. So this is a different robot arm, but we are using the same workflow engine, and we are using, let's say, similar BPMN processes, because the APIs need some of the reprogramming. So it's nearly the same BPMN, but with a different resource allocation in terms of APIs. And in order to generate this BPMN, we need a modeling tool to approach this BPMN workflow slowly. Now, there are different ways of doing this. I look at the watch. I know that I only have a couple of minutes left. I don't want to show you all of them. You can download, you can see the videos. We have PetriNets. Starting with PetriNets is very nice because you can access the robot arm directly. By the way, the robot arm can be accessed virtually. So everybody of you can access the robot arm as I do. You have to reserve a token and then the laboratory is for you and you can test it and play around. The PetriNet, you really have to know in detail what you are doing. We often use the flowcharts. So flowcharts are, let's say, for testing, it's very nice. And then you can transform the flowchart to a BPMN model and then test it actually in this environment. This is what I would like to show you now. Again, you can download the package, you can unzip the package, and then you start the BAT files in the sequence. There is a MySQL start, there is a Apache start. Now, this is the tool BUP. BUP is a tool which is provided by OMiLAB, and you can download it for free. And this means that the 5 famous modeling languages are concluded, which is BPMN, what is the E stands, ER diagram, EPC diagram, UML diagrams, and PetriNet. So this is inside this, in this tool. And here we have, for example, comply, and we have different ways of accessing this robot magician. So this is a very simple PetriNet. For example, if you like to first apple, then banana, then grape. So it's a pick and place with some symbols of cards. The flowchart looks exactly the same. Here you can execute. There is a Arduino script built in ArduXX. It's a script language for the models, which then accesses real APIs. If you would like to go to pre-binding, then it's a bit more, let's say, interesting, because you have a selection criteria at the front, and then you pick up the different fruits, and picking up different fruits are isolated terms. So in terms of modeling, you isolate the different, let's say, movements, and that access here the robot, for example, move to position. Here you have really the HTTPC send requests, and this is going to the URL of a Raspberry Pi that forwards the API to the robot. So this is the code that goes directly to the robot arm. Okay, and if you would like to have a late binding with BPMN, then you have this sequence. So you model this all this sequence, how to drop. So this is exactly move to the position, move to the shopping cart. So here you have the full BPMN process, and at the end you need to reset the arm. And this is then handed over to, here I need to start also the workflow engine. In that case, we are using Camunda because that is the workflow engine from the from the robot side. We as a modeler, we don't have any we don't have any preferences. So it's BPMN, and we export BPMN. Any workflow engine is fine for us. Good. Here you see the exported from ArduXX, well, in that case, BUP exported BPMN models. And here you see the X, Y, Z settings. And here, let me close all the windows, because now I hope everything is running. Because here you see the live camera in our laboratory. So that's the robot magician. Here are the cards. And now let's start the workflow. So let's run it. Where is it? I'm afraid that I'm a bit mixed up with all the different servers. Let me get the right dashboard. So, sorry, I started the wrong engine. Because I have to delete those running instances here, invoice receipt. Sorry, I started the wrong engine. Now, let me give 1 minute to sort this out. If I should delete now this or so. Because yesterday I prepared for this, but obviously there is a mistake. I didn't delete all of them. So, and now it seems that I cannot delete those dashboard running instances. So I actually, okay, I'm sorry. I started the wrong workflow engine. There is something going wrong. Let me show you the behavior from the tool itself. So this is a simple version, which is not the workflow, which I wanted to show you, but only the flowchart. So on the left, you see, let's say the pre-binding. Okay, let's make this one. I'm starting here. Let's say, let's go for the apples. And now I hope you see how the command is sent to the robot and is picking the apple. I apologize, actually, I wanted to show you this in the workflow engine, but I accidentally used the wrong workflow engine. Yeah, so now there is a command, the XYZ coordinates for the apple. And you see a little bit of delay here. So because of the camera, there is a little bit of trade-off. But you will see that the robot arm picked the apple. And of course, we can then also select a new one. In that case, it's the bananas. You also can see here in the flowchart that that you can always go back. So this is an endless loop till the point where you select no fruits. So basically, this is a way how you can react from a modeling tool to the robot. And if you would like to see this, let's say, working, I apologize for this. We have everything packaged here. So you can reserve a token, you can interact with a laboratory, and you can also perform this access this robot arm. Here are some samples, also the certification. And again, here is the download packages where you can download also some sample slides, and you can either show the PetriNet, or you can show the workflow engine, or you can test the flow chart. So I'm a bit difficult because here is this command line in my way. I now show you where to find it. The developer community, developer spaces, and all the interaction is comply. Let me say here, there is comply. And if you want to download, again, here is a fast deployment package with everything. And then there is like fixed binding, pre-binding, late binding with PetriNets, flowcharts, and BPMN workflow engine. how to use a robot arm, how to have the live stream, and of course videos where you can see the whole thing in live, well, the whole thing running. But for you today, I wanted to show it live. So reflection, where think lessons learned. Yeah, of course, we have the innovation laboratory for various support, but open questions where we ask the academic and research, what is a digital organization? What is the digital transformation? So how can we use these ontologies and semantic descriptions or whatever form of description to help this digital transformation? And then also how to educate the people that modeling also with different environments gets normal and day to day. So this education of digital workflow, and actually what is a global digital ecosystem. So what is inside this modeling environment and what is outside and how to interact. So these are questions, and with those questions, I hope I gave you an interesting overview of our innovation lab. I provided all the links for download, all the videos, all the material, and I hope this is a bit of inspiration, and we would very much appreciate if you test, try out, and come back to us. Thank you very much.
Okay, thank you very much, Robert. Indeed, definitely we all have at least till Christmas to check out everything what you showed to us right now. Do we have any questions to Robert? Is there something you would like to ask? I didn't see anything coming in the chat, but probably we have any questions right now. If that's not the case currently, I will ask one question. So probably with a reference to the Beamer case. You showed that you can do this business process simulation. And in my experience is with simulations, the problem is that the simulation model development is quite an ad hoc activity, or probably not ad hoc, but case to case. So essentially for different cases, you need to create pretty much new simulation model every time, and there is little of reuse basically, and it's quite an effort. How do you tackle this kind of issue? Do you have some kind of approaches to streamline simulation model development?
Well, streamlining simulation models, not yet. What we are doing is that we have different abstraction layers. So we have a high-level template. In that case, it was construction. And for example, the template is what are the standard steps in how to make a facade. And if you go to a concrete building, then you need an instantiation. And then it becomes to get more complex. And if you would like to observe it on a weekly basis, then you even have to go more down. So what we are doing is we always go on the higher level, because let's say these are generic processes which are valid for roughly valid for most of the cases, and then you give let's say a first estimation. And only if they say yes, but this particular building has some aspects, then you go into one level detail. And the level on a weekly setup is really only to look at very special indicators. For example, here the scaffolding. We are looking maybe also on the raw material, because a lot of material get lost at the construction site. So then you only look at very specific points, because otherwise, as you said, the effort would not pay off. You save a couple of €1,000 on raw material detection, but you're losing several thousands on building the simulation models. So my answer is we start very generic with a high, let's say, deviation, and then we go more and more into detail.
Okay, thank you very much. If someone else has a question, then please just jump in. But I might ask one more. That's a rather simple one. So you mentioned the certification of business processes. Mm-hmm. Do you think what kind of authority you would need for doing this certification of business processes, and what would be the approach, how to do it?
Here the answer is easy, because we are the tool provider, so we provide the technical facility and we have role A, role B, and role C, and good luck. So I think the core of your question, I'm afraid I cannot answer. What we have is, for example, we have experience with the legal departments, and they are very much on the application field. The security and safety is very much on the technical aspects. So what we currently identify, we are still not sure if this is true, that the legal aspects are very much on the application. So in which field, what is the education, who is doing the decisions, and which is, let's say, totally separate from security and safety, which really look on the technical infrastructure, where are the fans, and what is the distance of the robot arm, and what is the speed, etc., etc. The ethical issue is somewhere in between. We can hardly separate the legal and the ethical issues. It's somewhere on the application and somewhere on how this application decisions is done. This is also because you need a concrete application then here. So as a technical provider, we provide you a modeling tool that can certify a model, or can check if a model has been certified, and we can provide a questionnaire that the result of the questionnaire certifies a model or not. But who is doing it and who is taking the responsibility is really in the application field. And yeah, there I don't have a generic answer. I'm sorry.
Okay, thank you very much. Yes, and thanks once again for a very interesting presentation. And we actually recently had a discussion with Change to Tween representatives about possible collaboration and working on digital twin development. Okay, so thanks for your presentation. And here is actually one small present. I will send you over the mail, since we are not meeting in person. So I will send it over. That's a Latvian drink you could add in to coffee and something like that, basically.
Very good. Okay? Thank you very much. Thank you for the invitation.
Okay, and thank you. And then we have contributed paper sessions coming up. And as I put it in the Zoom chat, they are happening in a different Zoom room. So you are very welcome to join these sessions and to continue to participate in our conferences. Okay, goodbye, Robert, and see you. You will still need to chair one session later this afternoon.
Yeah. I'm here the full day. Okay. Thank you very much. Thank you.
Okay, take care. Bye.